All right, let's try to solve this question as well. So this is a little bit more complicated one. So this one is combination of both series and parallel combined. And right away, you know that the circuit goes from here and it divides one going this way and one going this way at this junction. So right away, you know that R1 and R2 together will get 5 volts. So 5 volts we're going to go to both of R1 and R2. So both R1 and R2 will get a 5 volts amount of power. And this voltage in parallel will keep going and it's going to split this way, it's going to split that way, it's going to split this way. So this will get 5 volts, this will get 5 volts, this will get 5 volts, but actually the 5 volts has to be shared between not just R4, R5, R6, but it has to be combined with R3. So this entire 4 resistor will get 5 volts. Okay. And so somebody might ask, what is the V total? So V total is 5 volts. So that's the total voltage that this circuit we're going to get. And they might ask you to figure out what is the I total, so total currents for this whole circuit. They might ask you what is the total resistance for the whole circuit. Then they're going to ask you what is the voltage 1, what is the voltage 2, what is the current at resistance 1, and what is the current at resistance 2, and so on and so forth for this entire circuit. So let's just do it one step at a time. First thing we need to figure out is the total current, and then total current we really can't figure it out unless we know the total resistance. So the only way to figure out the total resistance is figure out what is resistance of R1 and 2. So we're just gonna take care of this guy first. And then we're gonna figure out what is the total resistance of R3 plus R456. So we need to know what R3 is, which is 1 ohm, so that's kind of easy. R456 are in parallel, so we have to figure that out separately. R1 and 2, they're in series, so to each other. So R1 and 2 is equal to R1 plus R2. So R1, 2 is equal to 1 plus 1. So R1 and 2 together is 2 ohms. So that was done. Since they're like series, so they're pretty easy. R3 versus R456, they are series, so they should just be added up. But R4 and 5 and 6, they are parallel to each other, all three of them. So in order to figure out R456, we have to use the rule 1 over R456 is equal to, we have to use the formula 1 over RT is equal to 1 over R1 plus 1 over R2 dot dot dot. So 1 over R456 should be equal to 1 over R4 plus 1 over R5 plus 1 over R6. So in this case, 1 over R456 is equal to 1 over 1 plus 1 over 1 plus 1 over 1. And so 1 over R456 is equal to 3 over 1. So R456 is equal to 3. No, not 3. It's reciprocal of that. So it should be 1 over 3. Okay. So now that I know R456 is 1 over 3 ohms, which is 0.333 repeating. So I'm just going to say 0.33 ohms. So R3 plus R456, R3456 combined is 1.33 ohms. Okay. Now you have to know that R12 versus R3456, they're parallel to each other. So they're not series, but they're actually parallel to each other. So you cannot just add them. They're parallel to each other. So what you have to do is you have to use that equation again. Now RT is equal to 1 over R12 plus 1 over R3, 4, 5, 6. And that is equal to 1 over RT. So 1 over RT is equal to 1 over R12 is 2 ohms plus 1 over R3456 is 1.33 ohms. So in this case, you have to do the calculations, and 1 over 2 plus 1 over 1.33. 1.33, you could multiply it 3 times, and that should give you 4. So if you multiply it by 6 times, that should give you 8. So it's same as 4 over 8 ohms plus 1.33 times 3 would give you 4. So if you multiply by 6, you're going to get 8 ohms. And so you're going to get 6 here. So now what you're going to get is you're going to get 10 over 8. So 1 over RT So 1 over RT is equal to 10 over 8. Now if you take a reciprocal of both sides, then you're going to get RT is equal to 8 over 10. And 8 over 10 is 0.8 ohms. All right, so then now you have RT that is 0.8 ohms. And now the IT is equal to VT over RT. And VT is 5 volts over 0.8 ohms. So 5 divided by 0.8 is, let's check, 5 divided by 0.8, 6.25. 6.25 amps. All right. So that's how we figured out the entire, the total voltage and total current and total resistance. But now we have to go and figure out what is certain things we should keep as it is. So now we should go and figure out what is the voltage 1, voltage 2, and current. So let's figure those out. All right, so let's go back up. So what is the V1? Uh, so total resistance of R1 and 2 is 2 ohms. So V1 and 2 we knew was 5 volts. That's going to go up there. So it's 5 volts because they're parallel. And then I1 and 2 is equal to V12 over R12. And V12 was 5 volts. R1 and 2 was 2 ohms. So V12 is 2.5 amps. And since R1 and R2 are series to each other, they have the same current. So here I1 is equal to 2.5 amps, and V1 is equal to, well, V1, they're being shared, so we could calculate that out, or we can just divide 5 volt by 2, but we can calculate it out. I2, on the other hand, is same as the I1, so it's 2.5 amps. Now let's figure out the V1 and V2. So V1 is equal to I1 times R1, and I1 was 2.5